Good evening, students.
Good evening, ma'am.
Good evening,
Good
ma'am.
evening. Good evening, children.
Good evening, ma'am.
Hello, good evening. Yeah. So last class I was telling you that we have one more session of arithmetic progression, which includes the application part, okay, of this chapter. Meaning application part of the concept we use in arithmetic progression. Now, I'll just share that with you. I'll share the presentation with you. Share the presentation meaning I'll share the Word file with you, or maybe I'll upload the contents in the portal. So that because it's completely, like based on a situation, you need to read. I gave you one example in the last class. I think that was regarding an object being dropped from a height. It covers some distance in the first second, some distance in the second, and we had to find the distance it covers in 11 seconds, right? So questions of that kind, where arithmetic progression is applied. I have compiled all that already. I'll either share it on WhatsApp with you, or I'll upload it in the portal. So if it's uploaded in the portal, I'll let you know. You please log into the portal and work it out. Just go through everything, and then we may discuss in the next class. I think that's better than spending today's session on that one. So now that you know most of AP, you can be you will be able to help yourself with that, but still we need to discuss. I need to check if all of you have really got it. So that I'll do in the next class. So once I upload the contents in the portal, I'll let you know. I'll inform you when it's uploaded. Please practice before the next class on Thursday. And on Thursday, we shall have a discussion based on the same. So today, we are going to take up a new chapter, coordinate geometry. I said we'll do similar triangles. This coordinate geometry also will not take a long time for me. So I thought we'll just finish this and then move to similar triangles. Okay. So in this chapter, so we shall be dealing with two important formulae. One is called the distance formula. One is called the distance formula. And the other is called the section formula. Section formula. So this chapter basically was in three parts. Questions based on distance formula, questions based on section formula, and there was another part where we have the formula to find the area of a triangle. Finding the area of a scalene triangle using the coordinates of its vertices. Like in class 9, we have the Heron's formula, right? Heron's formula, where we make use of the sides, the length of the sides to find the area of the triangle. So like that here, we had the third part where we have a formula to find the area of a triangle with the help of with the help of the coordinates of its vertices. So if the triangle is ABC, coordinates of vertex A, coordinates of vertex B, coordinates of vertex C. So using the coordinates, we have a formula with the help of which we can find the area of the triangle. So that is deleted. That one is not there. So we only have these two, distance formula and section formula. Now, when do we use a distance formula? As the name suggests, distance formula is used to find the distance between 2 points. Okay, so in the Cartesian plane, if you have a point A given by the address 5, 2. Okay, let me show the quadrants. Okay. Okay, so in the Cartesian plane, say you have a point A. You have a point A given by the address -3, 5. And you have a point B given by the address 7, -2. Okay, B given by the address 7, -2. Now, distance formula will help you to find the distance between these 2 points A and B. The distance formula will help you find the distance between these 2 points A and B, or in other words, the length of the line segment AB. you can find the length of the line segment AB using the distance formula. So now the distance formula goes like this. We have the derivation. We're not doing that in today's class. So the formula goes like this. The distance between 2 points, or in this case, AB is equal to, in this case, AB is equal to, that is the length of the line segment AB is equal to. I said it is used to find the distance between 2 points. The 2 points are A and B. The distance between the 2 points A and B is nothing but the length of the line segment AB. So AB is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now we know that a minus b the whole square is the same as b minus a the whole square. A minus b is not equal to b minus a, but a minus b the whole square is equal to b minus a the whole square. You can take an example for that. Now 3 minus 5 the whole square is the same as 5 minus 3 the whole square. 3 minus 5 the whole square is minus 2 the whole square, and this one is 2 square. Minus 2 the whole square is minus 2 into minus 2, which is plus 4, and 2 square is 2 into 2, which is plus 4. So a minus b, this is always true. Not only for this example, this is always true. So a minus b the whole square is the same as b minus a the whole square. A minus b is not equal to b minus a. 3 minus 5 is not the same as 5 minus 3. But a minus b the whole square is the same as b minus a the whole square. So this formula can also be written as x1 minus x2 the whole square plus y1 minus y2 the whole square. Because x2 minus x1 the whole square, a minus b the whole square is the same as b minus a the whole square. So it can also be written as x1 minus x2 the whole square plus y2 minus y1 can be written as y1 minus y2 the whole square. So this can be modified and written in many ways. See, like you can write this one can be x1 minus x2 the whole square, but the second one can be y2 minus y1 the whole square. Any form is fine. Any form will give you the same correct answer. Or you can write AB is equal to square root of, you can write x2 minus x1 the whole square here and maintain y1 minus y2 the whole square here. I hope you understand. So it is a square root of, you can write x1 minus x2 the whole square or x2 minus x1 the whole square plus you can write y2 minus y1 the whole square or y1 minus y2 the whole square. And also you can write this one first and this one also later because it's only addition. It's only addition. So you can even write this one first and then this. So many variations you can do. You can say root of y2 minus y1 the whole square plus x2 minus x1 the whole square because it's plus in the middle. If it's minus, you cannot do that. The connecting sign is plus. So you can also say AB is equal to square root of, you can write y2 minus y1 the whole square plus x1 minus x2 the whole square. Okay, but the standard way of saying the formula is this one. The standard way is this one. AB is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now we have this point A, so you can call the coordinates x1, comma y1. Point B, coordinates x2, comma y2. The coordinates are not x1, x2. Every address has the x coordinate and the y coordinate. Every address has the x coordinate and the y coordinate. So any point is given by x1, comma y1, and the other one is x2, comma y2. It's not x1, x2, y1, y2. This one is x1. This is the x coordinate, which is x1. This is the y coordinate, which is y1. And here, the x coordinate, which is x2, and the y coordinate, which is y2. So we just have to put this in the formula. So square root of. So another thing I want to say is in words. How do you remember this formula in words? Okay. Now, we know that x1 and x2 are called the abscissae, the x coordinates, right? x1 and x2 are the abscissae of the points A and B. Abscissa is singular. Abscissa is plural. Abscissa is singular. Abscissa is plural, which means x coordinate. And the ordinate is nothing but the y coordinate. Ordinate, ordinates. Plural is ordinates. Abscissa is nothing but the x coordinate of a point, and ordinate is nothing but the y coordinate of a point. So when we say x2 minus x1 or x1 minus x2, it's simply the difference between the abscissae. It's a difference between the abscissae. See here, abscissae. See here, when you say x1 minus x2, this is x1 minus x2. What is x1? The x coordinate of point A. What is x2? The x coordinate of point B. I'll come again. x1 is the x coordinate of point A. x2 is the x coordinate of point B. And when you have to write x2 minus x1 or x1 minus x2, what is it? It's the difference between the x coordinates or the difference between the abscissae, the whole square. So in words, the square root of difference between abscissae, the whole square, plus y2 minus y1. We know that we can also write that as y1 minus y2 the whole square. It can be y2 minus y1 the whole square or y1 minus y2 the whole square. So basically it is the difference between the ordinates. Any order, difference between the ordinates or the y coordinates. y2 minus y1, y1 minus y2 is the difference between the y coordinates of the 2 points. So which can be written as difference between ordinates. So difference between, okay, BW, between ordinates, the whole square. So this is the formula. The distance between the 2 points or the length of the line segment is given by square root of difference between abscissae, the whole square, plus difference between ordinates, the whole square, or square root of difference between ordinates, the whole square, plus difference between abscissae, the whole square. Okay. So okay, so AB is equal to, you just have to subtract the x coordinate, any order. So you can write, listen to this very carefully, children. So you can write it in any way. So it can be minus 3, minus 7 the whole square. X1 is minus 3 and x2 is 7. You should write the difference. You must write the difference. So difference meaning minus 3, minus 7. Minus 3, minus 7. The whole square plus, you can use a simple bracket. Okay, so minus 3, minus 7, the whole square plus difference between the y coordinates. So 5, and this is minus 2. But you should find the difference. So minus 2, the whole square. This is x1, minus 3. This is x2, 7. Difference. So you should put a minus sign in the middle. You must put a minus sign in the middle. This is x1, this is x2. x1 minus x2, so minus 7. The whole square plus y1, 5. Minus y2, so minus 2. The whole square, which is equal to square root of minus 3 minus 7 is minus 10. The whole square, minus 10, the whole square is 100. And then here, 5 plus 2, 7. 7 squared, 49. So plus 49, which is nothing but the square root of 149. The square root of 149. Whatever units. So this is how we find the distance between 2 points in the Cartesian plane. Subtract the x coordinates in any order and square it, plus subtract the y coordinates in any order, square it. Square root of that sum. Is it fine, children? Yeah, please acknowledge.
Yes. Yes, ma'am.
Yes, ma'am.
All right. So supposing the points are like this, A is -3, -7, and B is minus 11 and minus, say like 5. Okay, so it will be square root of, these are the x coordinates. These are the x coordinates. Subtract them in any order. These are the x coordinates. So you should subtract them. Okay, so subtract them. So you can write -11 first. And then you can write -3. -11 first and then -3. You should subtract this. So you should take a minus sign in the middle. This is x2. This is x1. x2 minus x1, the whole square, plus. You can write anything. Now you can write this one first. You can write this one first. That is y1 minus y2. Just because this one already has a minus sign, you shouldn't think that, okay, I don't have to put this. So this is y1, this is y2, y1 minus y2, the whole square. So this will be square root of minus into minus plus. So -11 plus 3, -11 plus 3, -8, -8 the whole square, 64. Plus -7 plus 5, -2, -2 the whole square, 4. So square root of 68. Of course, you'll have to write it as a mixed result if possible. So I think 17 fours are 68 if I'm not wrong. So it is 2 root 17. So now instead of showing all this, you can also directly do this one. You can also directly do this one. What you can do is AB is equal to square root of, what is x2? Anything first? Okay, so if you write x2 first, x2, supposing you write this one, minus x1, right? So minus into minus plus, you can straight away put this like this. You don't have to show the minus and in the next step, do the simplification and all that. You can directly write this. Please write this directly. Please write this directly. Here. X2 minus x1 minus -3 minus -3. So -3 is plus 3, the whole square, plus, if you want to write this one first, -7 minus -5, -7 minus -5. So -5 is plus 5. So plus 5, the whole square. You can write, please write this step directly. Okay. Just make a note of the formula, children. One minute, let me clear the slide and show you what you have to write. Yeah. Please write down. This BW is between. BW is between. Done, children?
No, ma'am.
Okay. Yeah. Done, children?
One more minute, ma'am.
Yes, ma'am.
Okay. All right.
Done, ma'am.
Okay, very good. So next is the section formula. Section formula. So we have 2 points, x1, y1, x2, y2. And when you connect the 2 points, that is A, B, A given by x1, y1, B given by x2, y2. When you connect the 2 points, you have the line segment AB. Now let's say that there's a point P on the line segment AB, which divides AB in the ratio m:/n. Sometimes it's called m1, m2, m1, m2. It's the same. Okay, so the ratio can be m1:m2 or m:/n. So we have a line segment AB, A given by the coordinates x1, y1, and B, x2, y2. We have a point P on the line segment AB. P divides the line segment AB in the ratio m:/n. In the ratio m:/n. Now the direct application of the section formula is to find the coordinates of the point of division. Here P is called the point of division. The point P is called the point of division. Point of division because P divides the line segment AB into 2 parts, AP and PB. The point P divides the line segment AB into 2 parts, AP and PB. So P is called the point of division. The point P divides the line segment AB in the ratio m:/n. The direct use of the section formula is to find the coordinates of the point of division P. So the section formula is used to find the coordinates of the point P, normally given by x, y. Now, what do I mean by saying the direct use of the formula is to find the coordinates of P? What I mean is, now when you have the formula volume of cuboid is equal to L into B into H. So the direct application of the formula is to find the volume of the cuboid given the length, breadth, and height of the cuboid. The direct use of the formula is to find the volume of a cuboid given the length, breadth, and height of the cuboid. But the use of the formula does not end there. the use of this formula does not end there. It is not used only to find the volume of a cuboid. You can also find the length of a cuboid, length of the cuboid, given the volume, breadth, and height. Given the volume of the cuboid, breadth of the cuboid, and height of the cuboid, you can find the length of the cuboid using this formula. So basically, in the formula, we have 4 unknowns: volume, length, breadth, height. In this formula, we have 4 unknowns: volume, length, breadth, and height. Given any 3, you can find the 4th one using the formula. Given any 3. If you're given volume, length, and breadth, you can find the height. If you're given length, breadth, and height, you can find the volume. If you're given volume, length, and height, you can find the breadth. So they are the other applications or the other ways in which the formula is useful. The formula is not only used to find the volume given the length, breadth, and height. You can find the others also. Given sufficient information, you can find the others too. Like we understood, there are 4 unknowns. Given the values of any 3, you can find the 4th one. But the direct application is, we say volume of a cuboid is equal to L into B into H, meaning given the length, breadth, and height, you can find the volume. In the same way, the section formula is directly used to find this address, the address of P. The section formula is used to find the address of P. Address of P meaning the coordinates of the point P. It is used to find the x coordinate of the point of division P and the y coordinate of the point of division P. That's the direct use of the formula. But it can also be used to find other things. Like given the required information, you can find the ratio m is to n. Given the required information, you can find the coordinates of B. Given the required information, you can find the coordinates of A. So they are the other uses of section formula. We use a section formula not only to find the coordinates of the point P. That's the direct application. That's a direct use of the formula, to find the coordinates of the point P. But we use a section formula not only for that. We can also use a section formula given the required information. You can also use it to find the ratio in which P divides the line segment AB. You can use it to find the coordinates of A, coordinates of B, if they're not known. Okay. Please write down, children. I haven't still written the formula. Please complete this.
Completed, ma'am.
Yeah. Now this is called internal division, children. We learn only for internal division. There's also something called external division. That is, if this is the line segment AB, P will lie on AB produced. P will lie on AB produced. So we say that P divides the line segment AB externally in the ratio AP is to PB. AP is to PB. This is external division. We don't have this. We've never had this in our syllabus. So we learn only internal division, section formula. That is only internal division. Internal division, just for your knowledge. That is the division where the point P lies on the line segment AB, not on the line segment produced. P lies on AB, not on AB produced. If P lies on AB produced, it is external division. If P lies on the line segment AB, it is internal division. All right. Now coming to the formula. So you don't have to draw this again. I'm just, because I can't see the figure, I'm just
1
doing.
minute, can you go back?
Sure, sure. Yeah, 1 second. Yeah.
Thank you, Mama.
Yeah. So the x coordinate of P, the x coordinate of P, you can find it separately. Okay. The x coordinate of P is found using the expression. Okay, the x coordinate, this one, the x coordinate of P, which is x, is given by m x2 plus n x1 by m plus n. It's like cross multiplying, children. See here, it's like cross multiplying. Just write m n. 1 second. Let me show you here. See here, m n x1 y1 x2 y2. All right. See here, m x2 plus n x1 by m plus n. Like cross multiplying, you know, m x2 plus n x1 by m plus n. And to find the y coordinate of P, it is m y2 plus n y1 by m plus n. Use y1 and y2 to find the y coordinate of the point of division. Use x1 and x2 to find the x coordinate of the point of division P. Let's just see it again. To find the x coordinate of the point of division P. P is called the point of division. And P is a point, no? So in the Cartesian plane, it has an address. And the address is of the form x coordinate, comma, y coordinate. So what is the formula to find the x coordinate of this point P? It's given by, the expression is mx2, or the formula is mx2 plus n x1 divided by m plus n. And to find the y coordinate of the point of division P, the expression of the formula is my2 plus n y1 by m plus n. So the y coordinate of P is given by my2 plus n y1 by m plus n. If your school uses m1, m2, children, nothing to get confused. You should replace m and n with m1, m2. m1 x2 plus m2 x1 by m1 plus m2. Some schools use m1, m2 while others use ms to n. So there's nothing to get confused. If your school is using m1, m2, then x1, comma y1, x2, comma y2. So then the the formula to find the x coordinate of P will be m1 x2 plus m2 x1 by m1 plus m2. The y coordinate of P, m1 y2 plus m2 y1 by m1 plus m2. Please write down. Sometimes the formula is given like this, you can also write it like this in one line. P of x comma y is equal to mx2 plus nx1 by m plus n, comma my2 plus n y1 by m plus n. You can also write it like this. I normally don't write like this because I want children to, remember and register that you can use it separately. It's not one, it's not always, it need not always be used together like this. You can use this separately, use this separately. Supposing you want to find only the y coordinate of P, use only this. You don't have to use this if it's not asked. They're two independent expressions. They're not connected. Or you can also present it like this, or P x comma y is equal to mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. Or I mean, you can write like this, or you can write it like this, or you can write it like this. This is one way, or like this. Done, children?
Yes, ma'am. Completed.
Yes, ma'am.
Okay. Yeah. So this one is a section formula. Now, the midpoint formula, which is based on the section formula. Midpoint formula, which is based on the section formula. It's just an extension of the section formula. Midpoint formula. Now, what if P is the midpoint of AB? What if P is the midpoint of AB? Then M is to N will be 1:1. Now, here this is the generalized one. P is any point on AB. P is any point on AB. But this one is specific. This is a generalized one. P is any point on AB. Then this is how we find the x and y coordinate, x coordinate and the y coordinate of P. This one is a specific one where P is the midpoint of AB. What if the point of division P is the midpoint of AB? Then the ratio will be 1:1. This one is x1, comma y1. This is x2, comma y2. Then the x coordinate of P, x coordinate of P is equal to, the formula is what? mx2. So 1 into x2 plus nx1 by m plus n 1 plus 1, which is nothing but 1 into x2 is x2, 1 into x1 is x1. So you can just write x1 plus x2. It's x2 plus x1, what we're getting. You can write it as x1 plus x2 by 2. If P is any point on AB, then P is given by mx2 plus nx1 by m plus n. If P is the midpoint of AB, then the x coordinate of P is given by x1 plus x2 by 2. Because when you use the section formula, it is 1 into x2, m into x2, 1 into x2 plus n into x1, 1 into x1 by m plus n, 1 plus 1. So that amounts to x1 plus x2 by 2. The y coordinate of P is equal to m into y2 plus n into y1 by m plus n, 1 plus 1, which is nothing but y1 plus y2 by 2. y1 plus y2 by 2. So you can write it separately like this, or you can, if P is the midpoint of AB, then P x comma y is given by x1 plus x2 by 2, comma y1 plus y2 by 2. Yeah, right down, children. I'll just come back, children. Please write. Done, children?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right, children. Very good. Yeah. No, that's it. We are good to go. These are the, basic things which we need to know before we take up the questions from this chapter. So the distance formula, which is used to find the length of a line segment or the distance between 2 points. And the section formula, which helps us to find the coordinates, the x coordinate and the y coordinate of the point of division, P. That is, P lies on say this line segment AB, and P divides the line segment in the ratio m:2n. So if you want to know the address of P in the Cartesian plane, then we use a section formula. All right. So here we have a question. Find the distance between the points R given by A plus B, comma A minus B, and S given by the points, or the, sorry, and S given by the coordinates. I think I said points by mistake. Sorry. I'll read it again. Find the distance between the points R given by the address. Okay. Or given by A plus B, comma A minus B, X coordinate, comma Y coordinate, and S given by A minus B, comma minus A minus B. All right. So see here. So square root of your distance between the 2 points is nothing but the length of the line segment RS. It's nothing but the length of the line segment RS. So you can see here, I've written this one, the X coordinates. See here, this is the X coordinate, this is the X coordinate. I've written the X coordinates and subtract them, square it. Subtract the X coordinates, square it, plus subtract the Y coordinates. See here, subtract the Y coordinates. I'll have to write this one and this one, but this is already minus here. So minus into minus plus. That's why you see the plus sign here. How plus? This is the Y. This is Y. The Y coordinate of the point R. Write that. Minus the Y coordinate of point S. So minus into minus plus. So A plus B. The whole square. So this is the X coordinate of R. This is the X coordinate of S, like X1, X2, difference and whole square. Plus, this is Y1, this is Y2, but minus into minus plus, whole square. Now open the bracket, minus A minus into minus is plus B the whole square. Yeah, I think after this you can help yourself. Please write down, children. Do the step slowly and try to understand this one, children. If you have a question, please ask me. I'll work it in the earlier slide if this is not clear. Write this one correctly. After writing this, all this is fine. But if you go wrong in writing this one, the whole thing is wrong. Done, children?
Yes, ma'am.
Okay.
Completed, ma'am.
All right. So what is it? Square root of difference between the X coordinates, the whole square. plus difference between the y coordinates, the whole square. Here, if x comma y is equidistant from the points B and C. So there are 3 points in the question. There are 3 points in the question, A, B, and C. A is equidistant from B and C. A is equidistant from B and C. Equidistant does not represent midpoint. Now, A, B, and C should not be assumed to be collinear points. Okay, A is equidistant from B and C, so you should not take this assumption. So A is equidistant from B and C because A is the midpoint of BC. This one cannot be taken because it is not given that the points A, B, C are collinear. We just have 3 points. It's given, we just have 3 points A, B, and C. We cannot assume them to be 3 collinear points because when we have 3 points, they may be collinear, they may not be collinear. So you should always take that case where they're not. What if they're not collinear? What if they're not collinear? You cannot assume them to be collinear. We have 3 points A, B, and C. Do not assume them to be collinear because 3 points may be collinear, may not be collinear. Okay, so if they are collinear and A is the midpoint of BC, if A is the midpoint of BC, then A is equidistant from B and C. A is equidistant from B and C. But this you cannot assume. So we have 3 points A, B, and C. Okay, A, B, and C. A is equidistant from B and C, meaning the distance from A to B is the same as the distance from A to C. The distance from A to B is the same as the distance from A to C. So if you walk from A to B, 5 kilometers. If you walk from A to C, 5 kilometers. That is, the length of the line segment AB is equal to the length of the line segment AC. The length of the line segment AB is equal to the length of the line segment AC. The 3 points A, B, and C are not collinear. You should not assume them to be collinear. So we have them like this. A is equidistant from B and C. That means the distance from A to B is the same as the distance from A to C, which means AB is equal to AC. The distance AB is equal to the distance AC. So that condition is what you have to write first. AB is equal to AC. You can just make a representation like this. A is x comma y and B, A plus B comma B minus A, and C, A minus B comma A plus B. Okay, so you should start working with the condition. The condition is AB is equal to AC because A is equidistant from B and C. So AB is equal to AC means how do you find AB? Square root of x2 minus x1 the whole square. How do you write AB using the formula? Should subtract their x coordinates. This is the point A, this is the point B. Subtract their x coordinates. Subtract their x coordinates. So while subtracting the x coordinates, let me write this one first, A plus B first. A plus B minus x the whole square plus, let me write this one, this y coordinate first. See, you should use the address of A and B because you're finding AB. Don't see C now. You're finding AB. So use the address of A, use the address of B. C is not in picture now. So subtract the x coordinates of A and B. So A plus B minus x the whole square plus subtract the y coordinates B minus A minus y the whole square is equal to, I don't have place, so I'm writing to the next line, children, is equal to square root of Now AC. Now AC. So look at the coordinates of A and C. Don't see B, A and C. Now in A and C, we have the x coordinates, right? Subtract them. So let me write A minus B first and then minus x, the whole square, plus, let me write A plus B, the y coordinate of C, and then minus y, the whole square. Now we have square root on both the sides. So they get eliminated. They get eliminated. Correct? On both the sides, we have square root, so they get eliminated. So you can also write it as if AB is equal to AC, AB square is equal to AC square. If you write it like this, you don't have to put the square root symbol at all. You don't have to put the square root symbol at all. Don't get confused. If AB is equal to AC, that means AB square will be equal to AC square. Then you can just write x2 minus x1 the whole square plus y2 minus y1 the whole square. You don't have to put the square root symbol because AB square you're doing, right? You're writing AB square. If you're writing AB square, you don't put the square root symbol. AB is equal to AC, which means AB square is equal to AC square. So while writing the distance formula, because you're writing AB squared, don't put the square root. Simply write x2 minus x1 the whole square plus y2 minus y1 the whole square is equal to x2 minus x1 the whole square minus y2 minus y1 the whole square. Now it's very important. Now at this point, what you have to do is, if you have to expand this, it's going to be time consuming. You will have to use the identity A plus B plus C the whole square. Okay, who can tell me who can expand A plus B plus C the whole square? What is A plus B plus C the whole square?
Ma'am, it's A square plus B square plus C square plus twice AB plus BC plus CD, ma'am.
Correct. So when you expand that, you have 6 terms. A square plus B square plus C square plus 2AB plus 2BC plus 2C, 6 terms. Now, this is going to take time. It's not difficult, but it's time consuming. So what you can do is you should transpose, appropriately. Now, supposing you have this A plus B minus X the whole square on this side. On the right hand side, we have this one, right? Which also is made up of A, B, and X. If you look at both the sides, you have this one and this one made up of A, B, and X. You have this one and this one made up of A, B, and Y. So you collect A, B, X on one side, A, B, Y on the other side. So for this, you have to transpose. When you transpose, what happens is, so you have A plus B minus X the whole square in the left-hand side. So move this one. So it'll be minus A minus B minus X the whole square is equal to, you have A plus B minus Y the whole square already in the right-hand side. When you move it, minus B minus A minus Y the whole square. Simply transposing. Nothing else, just transposed. After using the distance formula, you can see that there are 4 expressions, 1, 2, 3, 4. This expression has A, B, and X. This one on the other side also has A, B, and X. So move this one to the left-hand side. So it becomes minus A minus B minus X the whole square. Similarly, this one is in the right-hand side, write it as it is. This one, when it's transposed, it becomes minus B minus A minus Y the whole square. Now you can treat it as a difference between 2 squares. You can treat it as A square minus B square, which is A plus B into A minus B. That becomes a lot more easier to save time. This is A square minus B square, which is A plus B into A minus B. Again, this one is like A square minus B square. So A plus B into A minus B. So like this, you can save time in calculating. Okay, you can see the answer here. After that is simple. Dear children, please don't start writing. Yeah. So A is equidistant from B and C. So AB is equal to AC or AB square is equal to AC square. So when you write AB square, AC square, see that square root is not there. That square root is not there because AB square you're writing. So the square root is not there. And then see I've transposed. I told you till here. Then I transpose. Then you can see I've written A plus B into A minus B. A plus B into A minus B. So and then You just have to open up the brackets, simplify, and this is what you get. This is what you get. You can take out 2 common. See, after this step, you can take out 2 common, children. So here there's 2 common, no, this one, 2, 2. So 2 I've taken out common. So you get a minus x and into 2b, into 2b. And here also 2 is common. So 2b minus 1 into 2a. So now this 2 into 2 is 4, 4b into a minus x. This 2 into 2 is 4, 4b into a minus x. 2 into 2a, 4a. 2 into 2a is 4a into b minus y. Into b minus y. So now this 4 and 4 on either side gets cancelled. B into a is ab, b into x, this one, a into b, ab, a into y, ay. Again, on either sides, you have AB and AB, so they get cancelled. We have AB on either sides. AB gets cancelled. So now I'm moving this here. Or you can just cancel the signs on both the sides. AB gets cancelled. Minus and minus gets cancelled. So BX is equal to AY. That's what we had to prove. Prove that BX is equal to AY. AB gets cancelled, and then the minus sign on either sides gets cancelled. So we have BX is equal to AY. Yeah, please take it down, children.
Ma'am, I have a doubt.
Yeah, sure.
Ma'am, can we use a midpoint formula for the same question?
No. The 3 points A, B, C can be collinear or non-collinear. So if you assume that they are collinear, then A will be the midpoint of B and C. A will be the midpoint of B, C. But you cannot do that. You cannot assume that. You cannot assume that the points are collinear and proceed. So this is a generalized one, that the points are not collinear.
Okay, ma'am.
Whenever it is equidistant, you'll have to assume that the points are not collinear. In very simple words, whenever it's given equidistant, do not assume that the points are collinear. We'll have 3 points. Don't assume them to be collinear. If it is the midpoint, it will be given. If the 3 points are collinear, then it will be given A is the midpoint of BC. If it's given A is the midpoint of BC, then that means A lies on BC. If A is the midpoint of BC, that means A lies on BC. In that case, A, B, and C are collinear.
Okay, ma'am.
Yeah. Done, children?
Yes, ma'am.
Yeah. So here, even if you expand using the formula a plus b plus c the whole square, you're going to get the same result. But it's going to be more tedious. It's going to be time consuming. You'll have to expand this carefully. You'll get 6 terms here, 6 terms, 6 terms, 6 terms. So when compared to that, this one will save time. But when you're transposing, you should transpose carefully. This one has A, B, and X. So this one, which also has A, B, and X, should be moved to the left-hand side, like this here. This one is A, B, and Y, which is in the right-hand side. So move its counterpart, B, A, and Y here. Move that to the other side. That way you will make it look like A minus B the whole square. Sorry, A square minus B square. That way you'll make it look like A square minus B square, A square minus B square, A square minus B square, which is A plus B into A minus B. On the other side, A plus B, A minus B. And then, you have to remove the brackets, simplify, that cancel out. Yeah. So in this question, find the relation between X and Y such that P X comma Y is equidistant from Q and R, is equidistant from Q and R. So point P given by the address X comma Y is equidistant from Q and R. Q 3 comma 6, R minus 3 comma 4. So the condition is PQ is equal to PR or PQ square is equal to PR square. So when you work this one, since we have X and Y, here, you will get a condition in X and Y. And that is a required relation. So see here. See here. So PQ is equal to PR or PQ square is equal to PR square. PQ square is equal to PR square. So how will you work PQ square? Don't put the square root symbol, that's all. Because for PQ, you should put the square root symbol. PQ square, so don't put the square root symbol. So it is difference between the X coordinates, the whole square, plus difference between the Y coordinates, whole square. Same thing here. And then if you want, you can expand it as it is. I have again transposed. So here transposing is not compulsory. See here you can, after writing this step, children, you can simply expand. What is A minus B the whole square? A square minus 2AB plus B square. Here also A square minus 2AB plus B square. You can expand. Here I have again used that earlier idea. That is, we have X minus 3 the whole square here. So I've moved this one here. I've moved this here. And we have Y minus 4 the whole square here. So I've moved this one to the other side, so that it looks like A square minus B square, A square minus B square. Again, I've used A plus B into A minus B on both the sides and then simplified. So on doing this, finally, you'll end up with a linear equation in X and Y. And that is the required relation. You'll end up with a linear equation in X and Y. And that is a required relation between X and Y. Yeah, please work, children. This representation is important. Please represent this. Done, children?
Yes, ma'am. Yes, ma'am.
Very good, yeah. Or I meant, I have worked it like this here. If you're not comfortable with this, you can also continue like this. It's not an alternate procedure or something. See, you can work it like this as you see here, or you can just write minus 6x is equal to 2y minus 10, and then bring everything to one side and divide by 2 throughout. You can also show it like this. So this is the required relation between x and y. 3 times x plus y minus 5 is equal to 0. 3 times x plus y minus 5 is equal to 0 is the required relation between x and y. Okay. So if A is equidistant from B and C, then find the value of P. Yeah, work this by yourself, children. Have this representation. AB is equal to AC, or AB square is equal to AC square. Work this.
Ma'am?
Yeah, Navya.
Ma'am, is P equal to minus 2?
Minus 2. No. No, I have a different value. Yeah, I have a different value.
Yes, ma'am, it's 1.
It's 1? Okay, thank you. It's simply subtracting the x coordinate. So 3 minus 0 the whole square plus p minus 2 the whole square is equal to p minus 0 the whole square plus 5 minus 2 the whole square. If you have to write AB, you should look at the coordinates of A and B only. When you're writing AC square, use the coordinates of A and C. When you're writing AC square, use the coordinates of A and C. And in A and C, subtract the x coordinates, square it, plus subtract the y coordinates, square it. Three minus 0 is 3. 3 square is 9. P minus 2 the whole square. You can expand it here. I've just written it as it is. You can also expand it here itself. P minus 0 the whole square is P. P minus 0 is P. P square is P square. And 5 minus 2 is 3. 3 square is 9. So 9 on either side gets cancelled. 9 on either side gets cancelled. Then you expand this a minus b the whole square. A square minus 2ab plus b square is equal to p square. Now p square on either side gets cancelled. So we have minus 4p is equal to minus 4. P is equal to 1. Shall we go to the next one, children?
Yes, ma'am.
Okay, thank you. Now, find the equation of the perpendicular bisector of the line segment joining the points A and B. Also find its point of intersection with the x-axis and the y-axis. So the 2 points given here are A and B. Okay. A, B. A, don't write anything. Please listen, don't write. So we have the line segment AB. We know the address of A and B. Now we have to take up the perpendicular bisector of this line segment. We know that the perpendicular bisector is not a line segment, but a line. Perpendicular bisector is a line. Okay, so how do you construct the perpendicular bisector? Remember, take more than half of AB. Take more than half of AB, cut an arc here, and with the same radius, put your composite B and cut the earlier arcs. Cut the earlier arcs. And when you join, this is the perpendicular bisector of AB. So that's what is this line. That's what is this line. Okay, so let L be the perpendicular bisector. Let L be the perpendicular bisector of AB. Now, what is the question? We know that L is a line. We have a line segment AB, or we have to consider its perpendicular bisector. So we have called that L. L acts as the perpendicular bisector of the line segment AB. So what is the question? The question is to find the equation of the line L. The question is to find the equation of the line L. We know that every straight line is given by a linear equation in 2 variables x and y. Every straight line can be represented by a linear equation in 2 variables x and y. So that is what you are expected to find. What is the equation of this line L? Who is L? L is the perpendicular bisector of the line segment AB. Now you are expected to write the equation of the line L. After that, you have to, with the help of the equation of the perpendicular bisector, you have to answer these 2 questions. Find the point of intersection. You should find the point of intersection of the perpendicular bisector with the x-axis and the y-axis. Let me make a more realistic, representation so that you understand the question better. Let me plot 7, 1 in the Cartesian plane. So 7, 1 somewhere here. Okay, A 7, 1, B 3, 5, 3, 5, B is 3, 5. Okay. 3, 5. Now, this is the line segment AB. And the perpendicular bisector will somewhat be like this. It'll go in the middle, children. Just excuse me, I'm just trying to show you how it looks like. Now you can see that the perpendicular bisector, it cuts the x-axis at this point and the y-axis at this point. You can see that the perpendicular bisector of L, see, it's not running in the middle of AB, children. Just excuse me, I'm just representing it. So don't be very particular that it's not going in the middle. Okay. So now this is the line L, which is the perpendicular bisector of the line segment AB. See, if the line is like this, the perpendicular bisector will go like this. Because it should make 90 degrees also. It should make 90 degrees. Also, it should go through the midpoint of AB. Okay, so you can see that the perpendicular bisector of the line segment AB intersects the x-axis at this point and the y-axis at this point. So that is, they are also the questions which you have to answer. You will have to find the address of this point and the address of this point. Where does the line L or where does the perpendicular bisector of AB cut the x-axis and the y-axis? So that is, what is the address of this point? What is the address of this point? So you'll have to answer 3 questions and all. First, you should find the equation of the perpendicular bisector of the line segment AB. Then you will have to find the coordinates of the point where the perpendicular bisector cuts the x-axis and the y-axis. Okay. So now let me take it like this. So now we know that every point on the perpendicular bisector, 1 second, children. Yeah, so we know that any point on the perpendicular bisector, you take any point on the perpendicular bisector. You say you take a point P here or you take a point Q here. Any point on the perpendicular bisector will be equidistant from the ends of the line segment. So that is, if you mark this point P on L, if you join PA will be equal to PB. The reason is because you can show that these two triangles are congruent to each other. You can show that these two triangles are congruent to each other. So CPCT, that is corresponding parts of congruent triangles are congruent. So PA is equal to PB. So PA is equal to PB. PA is equal to, take any point. You can take any point on the line segment. I'm sorry, you can take any point on the perpendicular bisector L. So we have marked the point P on the perpendicular bisector L. Now PA will be equal to PB. It's not given anywhere. You don't have to prove it also. Okay. But because, so PA will be equal to PB because you can show that these two triangles are congruent to each other. If I mark this point O, triangle POA is congruent to triangle POB because PO is the common side, 90 degrees, and OA is equal to OB because perpendicular bisector, no? So OA will be equal to OB. So by SAS congruence criterion, the two triangles are congruent. PA is equal to PB, CPCTC. But you can just write PA is equal to PB. So when you work that PA, so let P be given by the address X, Y, because you don't know, no? You've taken a point P, then you should also use it, you give an address to the point P. So let P be given by the address X, Y. The condition is PA is equal to PB. So we worked with that condition earlier also. And the result we get, you will get is a linear equation in X and Y. I'll just copy that equation which we get. Yeah, so you can see I'm getting, we'll get X minus Y minus 2 is equal to 0. the equation we'll get is x minus y minus 2 is equal to 0. X minus y minus 2 is equal to 0. This is the equation of the line L. This is the equation of the line L. Which means every point on the line L will satisfy this equation. Every point on the line L will satisfy this equation. Now, for example, there is a point, say that 6, 4 is a point on L. L, when it runs through the Cartesian plane, on L, there'll be so many points. This L in the Cartesian plane, there'll be so many points on L. Every point on L will satisfy this equation because this is the equation of the line L. If this is the equation of the line L, then every point lying on L should satisfy this equation. So, for example, we'll say that 6, 4 lies on L. When you actually do it on the graph paper, you will see that this point 6, 4 lies on L, which means when you substitute x as 6 and y as 4 minus 2. So 2 minus 2, 0. So like this, every point that lies on L will satisfy this equation x minus y minus 2 is equal to 0. All right. So now when this line L cuts the x-axis, when the line L cuts the x-axis, its y coordinate will be 0 because on the x-axis, the y coordinate is always 0. So when you take y as 0, why should you take y as 0? Because where L cuts the x-axis, L cuts the x-axis, the address will be like x, 0. And where L cuts the y-axis, the address of that point will be like 0, y. This is the line segment. Okay. So L cuts, this is the line L. This is the line L. This is the line segment AB. This is the line segment AB. Now L cuts the x-axis here. The address of this point will be like x, 0. L cuts the y-axis here. The address of this point will be like 0, y. So you should take y as 0 and find the corresponding value of x. Take y as 0 and find the corresponding value of x. Okay, take y as 0. So when y is 0, you'll get x minus 0 minus 2 is equal to 0. So x is equal to 2. When y is 0, x is 2. That is, you should always see address is always written like x, y, x coordinate, y coordinate. So x is 2, y is 0. So 2, 0. So the address of this point is 2, 0. So the line L intersects the x-axis at the point 2, 0. The line L intersects the x-axis at the point 2, 0. Now you also want to find where it meets the y-axis. So for that you have to take x as 0. See, you should take x as 0 and find the corresponding value of y. So when x is 0, 0 minus y minus 2 is equal to 0. So minus y is equal to 2 or y is equal to minus 2. Y is equal to minus 2. The address is of the form 0, y. So 0, minus 2. Y is minus 2. No? So 0, minus 2. So 0, minus 2. The line L intersects the y-axis at the point 0, minus 2. So because the the format in which every point will look like on the x-axis and y-axis, you should make use of that format. So any point on the x-axis will be of the form x, 0. Any point on the y-axis will be of the form 0, y. So when you take y as 0 and find the corresponding value of x, when you take y as 0 and find the corresponding value of x, you will know where the line cuts the x-axis. If you take x as 0 and find the corresponding value of y, that will be the point where the line meets the y-axis. Please work with the help of the slide, children. As you work, any questions you can ask me. This one is very tiny. I'll just write it. AB is a line segment, so it starts here, it ends here. But L is a line. L is a line. L is the perpendicular bisector of AB, and we have just taken a random point P on L. We have taken a random point P on L given by x comma y, and PA is equal to PB. Online students, oh, all of you are online, I'm sorry. Yeah, students, use the emoji, raise your hand. Sashank, Kritika, Krishni, Prajit, Florentina, Madhumita, Raja, Rakshita, Raghavi, Tanishka, Navya, Sri Ranjan, Arjun, Danya and Dilipan, you're there, right? Danya, very good. Dilipan. Are you there, Dilipan? No response. All right. Yeah, Chidam, please continue. And just get back, children, please write. So here I've cancelled the minus 4 on both the sides, and then we have 2x minus 10 is equal to 2y minus 6. When you bring everything to one side, 2x minus 2y minus 4 is equal to 0. When you divide by 2 throughout, you get x minus y minus 2 is equal to 0. And that is the equation of the perpendicular bisector. This is perpendicular bisector of AB. So we got the equation of the perpendicular bisector. Now we'll have to find where that line intersects the x-axis and the y-axis. Completed, children?
Yes, ma'am.
Okay. Others?
Yes, ma'am.
Completed, ma'am.
All right.
Completed, ma'am.
Very good, children. All right. So you can try this as homework. Take this question. Please take this question and try it as homework. All right. So here the question is, find the value of x if the distance between the points A and B is 5. So let's represent the information diagrammatically. A, x comma 1, x comma minus 1, B, 3 comma 2. And the distance between A and B, that is the length of the line segment AB is 5 units. AB is 5 units. So we know that the length of the line segment AB is 5. We know that AB is 5. The length of the line segment AB is 5 units. We know it. So how do you find AB? Square root of AB. How do you find AB? Square root of, subtract the x coordinates. So x minus 3, square it, plus subtract the y coordinates. So 2 minus minus 1. 2 minus minus 1. So 2 plus 1. The whole square is equal to 5. So work this square on both the sides to get rid of the square root symbol. Continue, children, and find the value of x. You may get one value or two values for x. Yes, children. Got the result?
Ma'am, I got two values.
Yeah, that's what I said. You will get.
Yeah. One is 7 and one is -1.
7 and -1. Yeah, you're right. 7 and
Ma'am,
-1. Yeah.
even I got 7 -1.
Okay, that's good. Yes. So it's like this. B is given by 3, -2. Sorry. Oh my God, what's wrong with me? B is given by the address 3, 2. So 3, 2, somewhere here. B is 3, 2. Now we have two values for x. Let's understand why we are getting two values for x. So we get x is 7 or -1. 7 -1. So when x is 7, the address of A is 7, -1. So where is 7, -1 here? 3, so 7, -1. Okay, 7, -1, A. The other one is -1, -1, -1, -1. So here is -1, -1. That's because whether the point A is located here or here, the length of the line segment AB, because this one is fixed. If both the points are not, see this one is fixed -1, this is fixed. So you're getting two different values for x. You're getting two different values for x. So -1 can be plotted anywhere here, -1 here like this. So the two values for x are 7 and -1, which means 7, -1 or -1, -1. So this is -1, -1. This is 7, -1. The distance AB here will be 5 units. The distance AB like this also will be 5 units. The distance between the 2 points A and B should be 5 units. For A, the y coordinate is fixed. For A, the y coordinate is fixed. So you have to find out the x coordinate. So the x coordinate can be 7 or -1. So if it is 7, -1, it's here. If it is -1, -1, it's here. We're getting two values or two addresses because if A is located here, AB is 5 units. If A is located here, then AB is 5 units. Okay, so check your working. So I've squared it in the first place itself. So this is also fine. AB is 5, meaning AB square is 25. So when you're writing AB square, you don't put the square root symbol because you've squared it, no? So don't put the square root symbol. AB is 5 means AB square is 25, squaring on both the sides. So then don't put the square root symbol. You don't have to write A is 7, -1 or A is -1, -1 because they've not asked you that question. The question is only to find the value of x, value or values of x. So just leave it here. X is 7 or x is -1. That's it. Next one. If the points A and B are on the circle with center O, then find the value of x. Circle, center O, given by the address 2, 3. A and B lie on the circle. So A, 4, 3, B, x, 5. The 2 points A and B, they lie on the circle. And the center of the circle is given by the address 2, 3. Find the value of x. So you'll have to create a condition here. You should always create a, if the condition is given, write the condition and work with the condition. If no condition is given, you can, based on the situation, you can create a condition. So what is the condition here? Or what is that equation which you can construct here, children? In this
OA
situation.
is equal to OB, ma'am.
Perfect. Very good, children. Yes. OA is equal to OB. OA is equal to OB because OA is radius, OB is also radius. So you should write that condition first. OA is equal to OB. Then you can write OA square is equal to, therefore OA square is equal to OB square. Yeah, work that and find the value of x. Please work. This is the condition. OA is equal to OB. OA square is equal to OB square.
Ma'am, is x equals 2?
X is 2, is it?
Yes, ma'am.
Okay. Yeah. Perfect. Done, children?
Yes, ma'am.
Very good. Yeah. Find a point on the x-axis. Find a point on the x-axis which is equidistant from the points -2, 5 and 2, -3.
Ma'am, could you please show the previous slide for a second?
Yeah, sure, sure. Yeah.
Thank you, ma'am.
So we need to find a point on the x-axis. We know that every point on the x-axis will be of the form x comma 0. Every point on the y-axis will be of the form 0 comma y. Okay, so now we have to find a point on the x-axis. So let the point be given by the address x comma 0. X comma 0. See, on the x-axis, y is always 0. Every point on the x-axis, see what is this? 1 comma 0. This one 2 comma 0. This one minus 1 comma 0. This one say minus 4 comma 0. On the x-axis, y is always 0. So any point on the x-axis will be of the form x comma 0. On the y-axis, this one is say 0 comma 1. This one is 0 comma 5. This is 0 comma minus 7. So on the y-axis, x is always 0. On the y-axis, every point is of the form 0 comma y. So let that point P on the x-axis be given by the address x comma 0. Now it's equidistant from A and B. It's equidistant from A and B. So if it's equidistant, the condition is PA is equal to PB or PA square is equal to PB square. You can complete this later, children. Just take down to this extent, leave some place. One more sum and we'll wind up the session for today. Yeah, done, children? You can complete this later. Yeah, next one. Find the point on the y-axis equidistant from A and B. So let the point P on the y-axis be 0 comma y. Because we know that every point on the y-axis will be of this form 0 comma y. Now this is the equidistant from A and B. A 2 comma 3, B minus 4 comma 1. So again the condition PA is equal to PB or PA square is equal to PB square. Work this and find the value of y. And hence you should write the address. So find a point. So you will find the value of y. So the point is, supposing y is 5, therefore the required point is 0 comma 5. Supposing you get y is equal to 5, don't leave it there. The question is find the point. So the point is 0 comma y or 0 comma 5. Done, children?
Yes, ma'am.
Yeah. All right. Please complete these two, children. Two, I think three. Two now and one perpendicular bisector. Find the equation of the perpendicular bisector and then where it meets the x and y axis. So I think you have three in all. Please complete this by the next class. So as I told you, I'll share the material on arithmetic progression in the portal, mostly in the portal, and I'll let you know once it's there. So you can go through and work out if time permits for you. So, and then we'll discuss that in the next class. All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you, ma'am.
Thank you,
Bye.
ma'am.
Thank you, ma'am.
Thank you,
Thank you,
ma'am.
children. Thank you, children. Good night.